Today's daily dose of math is about mean deviation. Mean deviation is a pretty easy formula to use to calculate the average distance the values in a set of data have from the mean. And before you can calculate mean deviation, you already have to know the mean. I'm not really showing a formula for mean deviation here, I'm showing the calculations though. So in our example, we have this data, 235899. The n, the sample size, is 6. There are 6 values here. And the total of those values, sigma x, is 36. If I add these 6 numbers together, I get 36. So the mean, therefore, is going to be equal to 36 divided by 6. The mean is 6. The average is 6. Now, when I calculate mean deviation, what I do is I keep taking the mean and subtracting one of the data values. So first I'm going to do 6 minus 2. And the difference is 4. The distance between 2 and 6 is 4, if you will. Now what we like to do though when we do this is we like to say the absolute value of the distance. So these bars mean that we're looking for the absolute value, meaning we want the answer to be 4. And even if what happened when we subtracted was negative, we would still say it's positive 4. That's all absolute value does. So that's not really necessary when I do 6 minus 2 because the answer was already positive. But eventually you get to data points where it's necessary. Doing this for all of the 6 values, we have 6 minus 3 is 3. 6 minus 5 is 1. And now we're getting to values that are bigger than 6. The absolute value of 6 minus 8 is not negative 2. It's the absolute value of negative 2, which is 2. Now you see why I'm doing this. I don't want to say that 8 is negative 2 values away from 6. It's 2. Distance can't be negative. So if we do this with 9, we have the absolute value of 6 minus 9, which we do twice, because we have 2 9s in our data. And the answers are both positive 3. To calculate mean deviation, we take all of these answers we get when we do the subtractions, and we add them together and divide by the n, the sample size again. 4, 3, 1 go here, and 2, 3, and 3. When we add these together, we get 16. We divide that by 6, and our answer is 2.67. The mean deviation of this data is 2.67. Now we can look at it like this, that if we have these numbers arranged from 1 to 10 and we show where 6 is, which is our mean, and then we show where all of these other data points would fall, we're able to see that 2 is 4 spaces away from 6, 3 is 3 spaces away, 5 is 1 space away, and then even though 8, 9, and 9 are larger than 6, 8 is 2 spaces away from 6, 9 is 3 away, and the other 9, of course, is also 3 away. So these distances from 6 are what we're measuring when we do this. And the answers to that are what goes into the numerator in this formula. That is mean deviation. It's today's daily dose of math. Please like, subscribe, and share.